This is the first lesson in our unit on statistics. Learning target 1 is the line of best fit. How do you find a line of best fit for a data set and use it to calculate errors and predictions? So we're going to talk about a bunch of different things in this lesson. First off, a line of best fit. It's also called a linear regression. And there are a lot of important pieces to a line of best fit. What is this line best fitting? It's best fitting a data set. And a data set is usually given in the form of a table. Here's a table of the number of years since 1997 and the number of alternate fuel cars that were in a state during those times. We have our X's and we have our Y's, our inputs and outputs. There's also a spot in the data that is perfectly balanced. It's called the balance point. You find the balance point by finding the average of the X's and the average of the Y's. That's what this little line above the X and the Y mean. It means average. And if you remember, to find an average, we take all the X's and we add them all up and we divide by how many there are. So 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 7. We take all the Y's, we add them up, and we divide by 7. And if we do that, we end up with a point that perfectly balances all the numbers. It's kind of like right smack in the middle. So the balance point for this data set is x3 and a y of 385.5. So now let's use Desmos in order to actually run the linear regression and find a line of best fit. To use Desmos to run a linear regression, go up to the bars that are up here in the upper left corner and scroll down until you see a spot that says Statistics Linear Regression. This is a tool that will help you actually find the line of best fit. They start you off with just some fake points. I want you to go ahead and delete all these points. And we'll actually put in our own points. Let's zoom out so we can see all of those points. And they're way up there. So this is kind of a funky way to look at this graph. I don't need to have all these X's going all the way up into the thousands. So hit the little gear, the little wrench thing up in the corner to change the settings. For X's, I don't really want it to be that big or really be that small. So instead, let's have it only start at 0. And since the X's only go up to 6, I think I'll have them stop at about 8. There we go. Now I can see my points nicely. So I see that there's a line here that kind of goes pretty much in between all the different data points. Also down, we notice in the left-hand column is a bunch of information. So things to know about what it's telling you. First off, it's giving you an equation in the form of y equals mx plus b, which is slope-intercept form. It's telling you what the m is, 41, so you would plug a 41 into this m spot. It's telling you what the b is, 262.5. You should plug that into the b spot. And then you actually have an equation for this line. Also, the b is the y-intercept, so 262 is where that line is actually intercepting, the y-axis. Another important thing to notice is this R value. R is equal to 0.99. We're going to talk about that more in just a little bit. So here are all the important pieces of a line of best fit. We have the data set, which are all the X's and Y's for our scatter plot. The scatter plot shows where all the points are. We have a balance point, which is a point that is on the line of best fit. And you should always have a balance point on the line of best fit. This is very important. You should always know where that is. We have an equation for this line, y equals 41x plus 262.6. And you see that it kind of travels pretty much between all of the points. So here are some steps for using Desmos in case you kind of forgot or got lost as I was using the tool. If you need to, pause the video and go ahead and write down these steps. But the steps in general are: step 1, go to desmos.com and click on the bars in the upper left and use the linear regression tool. You then enter all your data into the table, and then down below the table it will show you what the line of best fit equation is, and it will show you a picture of the scatter plot and the line traveling through it. Remember, if the picture doesn't look good, you can always use the wrench in the upper right corner to change the way that the graph looks. You then also calculate the balance point by hand. You do that by adding up the x's and dividing by how many there are, and add up the y's and divide by how many there are. That is the balance point. Now, some points actually are above and some points are actually below a line of best fit. Okay, understanding what this means is understanding residuals or understanding error. To calculate the error of a line of best fit, what we can do is we can kind of extend our table past the input, the output, past the x and the y into a column for predicted and a column for error. Now, I'm going to go ahead and input all of these into my Desmos tool, and I'm going to use that linear regression Desmos tool to give me a line of best fit. I've entered all of my points into the Desmos tool and for linear regression, and it gave me an equation of y equals 7.7 x plus 6.4. And I'm going to use that equation to find these predicted values. I do that by taking each of the x's and plugging them into this equation and working out those values. 7.7 times 0 plus 6.4 is 6.4. I continue to plug in the rest of my x's to get the rest of my predicted values. They turn out to be these values. That's plugging in 3, plugging in 4, plugging in 5, and plugging in 6. I then take my output minus my predicted. In a sense, we take our y's and we subtract the predicted, and that's how we find out the error of each of these. So 8 minus 6.4 is 1.6. 15 minus 14.1 is 0.9. 20 minus 21.8 is a negative 1.8. So as I look down the errors, I notice that some are much larger than others, some are positive and some are negative. Things to know about this: errors that are positive are actually above the line. Errors that are negative are below the line of best fit. And if you had an error that was 0, it would actually be on the line of best fit. So some of these points are much closer to the line of best fit than others. So this is what we refer to as the errors. Understanding how close the lines are to the line of best fit is understanding correlation. A correlation is how close the points are together, or how close they are to the line of best fit. There is a number that represents this closeness. This letter is called R. They're called the R values. If the points completely perfectly line up with a line of best fit, we call this a perfect correlation, an R of 1. Different lines of best fit have different R values. And the closer they are to 1 or -1. If the points tend to go up to the right, we call that positive. So this would be positive perfect. Positive strong, the points are still very close to the line, but they're not exactly on the line. So something like 0.8. 0.3 would be moderate. Something like 0.1 would be low or weak. If there is no real way to draw a line and the points are just spread out in a big blobby cloud, we call that a zero correlation, no relationship at all. If the points tend to go down, we call that a negative. So, if the points are really close to the line, 1 or something close to 1. If the points are far away from the line, have it be much smaller, like 0.3, 0.2, or 0.1. This is the same for negatives, except that if the points tend to go down to the right, we use those same R values but with a negative sign. So direction is the positive negative. Do the points go up or do the points go down? Strong, moderate, weak, or none is how close the points are to the line of best fit. Is it strong? They're close. Moderate, weak? They're spread out, or is there no relationship at all? And you could have a line that best fits the data, or it could be a curve. So let's take an example to kind of understand how to approximate these things. So in this example here, I have points that are a little more close together in the beginning, and then they don't really follow a line. They kind of curve off to the side. I would say if I were to just draw something that fits in between these lines, I might draw something like this. So I would say that the form of this graph isn't really a line. I'd say it's more curved. The direction is definitely going up, right? It's going up. So it is a positive direction. Would we say that the points are all very close to this curve? Kind of close, or very weak and very far away? I would probably say that there are quite a few points that are pretty close to this approximate curve. So I would say that it has a moderate strength. Yes, you have these outliers, but a lot of the points are relatively close to my approximation. So what R value would I give? Remember, the R values go from 1 to 0 to -1. So where in this range do I feel it's going? Well, since it's positive, I'm not going to think about down to -1. Where in between 1 and 0? Well, I would say there's a lot of points close, so maybe give this about a 0.3 or a 0.4. It's about moderate. It's not strong or weak, but there is a relationship. There's about a moderate relationship. So this scatter plot has a positive, moderate, curved direction, strength, and form. Okay, I know that's a lot of information to cover in one lesson, but these are the important pieces of line of best fit, correlation, and scatter plots. If you have questions, don't hesitate to send me a message, and I'll get back to you as soon as I can. If you have questions that you want to bring in the class, write them down in your left column and share them out with your group. Don't forget to hit the submit button and answer your questions after the video.